Okay, good morning everybody. My name is Falk Huettmann. I'm from Alaska. For me it's very hot here. Alaska is much colder. I'd like to talk about climate change and biodiversity, and I have a second talk in the afternoon where I talk a little bit more about the theoretical underpinning and the environmental issues. Here I like to talk specifically, and I hope it's in your interest, about GIS modeling and how you can forecast and predict and data mine huge databases dealing with biodiversity in the context of climate change. So I also show you some forecasting, but this talk here is more technical, whereas the talk in the afternoon is more dealing with the whole environmental problem overall. Obviously, you hear me speaking, and by my name you realize I'm born and raised in Alaska. I'm German, obviously. I lived there only in Alaska since 10 years. I've been before in Canada, and I highly enjoy to interact and to work with Salford systems. That has been a very great experience of my own academic and professional career. I learned about CARD in the 90s when working with a colleague in Oregon, Maine at that time, and that has been a great ride. Constantly struggling with the statistics departments because they're all based on frequency statistics, which is completely not what we do. So I will talk about it in the afternoon as well, but this is an interesting experience to work with the tree-based algorithms in this subject. I'm running a lab called the eWay lab that deals with ecology, wildlife habitat, and then mostly data analysis. And I do it for the land, but I also do it for the ocean. So I work really truly global, truly worldwide, and we have these data from the whole world that we analyze for all sorts of animals. Now, in my own work, my own career, I have some heroes that I obey to a lot. I don't know if you know all of them. In the classic sense, you probably know Karl Popper, who invented the idea of hypothesis testing. But on the same line, I would actually put Leo Breiman, who invented obviously the CARD methods or promoted them, the tree-based methods. There have been other people that also have been very influential in the environmental field, but I like to stretch here that the statistical and mathematical underlying in how we deal with environmental issues are almost on the same level, or if not even bigger, than let's say what Felix Stillmark has done in Asia and in Russia for national parks. He's a very famous person in Russia. Or like Herman Daly, who worked on ecological economics. It's a different type of economy that wouldn't bring us down in this economic slump that we have right now. Or even David Carlson, who has organized the International Polar Year, dealing with worldwide with all the polar data. It's a very big achievement, I think. But again, I like to put Leo Breiman in the same context there because he really deserves that type of award or recognition in the environmental discipline. I know that Leo Breiman probably wouldn't perceive himself as an environmentalist or something, but he definitely is there just in terms of achievement, and you see that later why I say that. Now, I entered this discipline of academia almost 20 years ago. However, there are many landmines in academia. If you want to get tenured, if you want to get funding and so on, and we have a lot of battles around these issues. My own work is mostly centered around GIS, I should explain it to you later, but machine learning is part of this. I use machine learning and data mining techniques, and they have been heavily criticized by my colleagues, although we constantly show the other side that these methods work so well. We also use machine learning and data mining in the context of, again, GIS, metadata, and we handle economic questions a lot, social problems a lot, we deal with sustainable management issues. We've also moved into disease modeling. Most of our work is predictive, and then we also share data. These are all issues that academia, to this very day, including the National Science Foundation, hasn't resolved at all, I would say. Although they say so, but in reality it's not. You get actually punished if you work on these issues. But regardless, that's something what I call a landmine, and data mining is part of this, but we are progressing. It's very central for us that we work with predictions. That is also new to my colleagues because usually they work reactive, so they have a statistical problem, they analyze it and say that was the problem, that was the situation that has caused it, that is a mechanism and the underlying reason. What we are trying to do is we're trying to say what is actually probably the forthcoming reason for a problem. So we're trying to move into a proactive situation, which obviously if you're involved in business, you know that you want to avoid any problems before you run bankrupt. Environmentally, we've always done it afterwards. First we can run environmentally bankrupt, and then we say, oh, there was a problem. Now, we're trying to change that. In medical situation that it's well known that you want to predict the outbreak of a disease, for instance, before a disease really occurs. Anyway, in the environmental field, we haven't done that so much. But that's what we're moving into. And so therefore, we are quantitative, spatial. We work with the spatial and statistical interactions. We usually try to have one formula, one algorithm, like the random forest, let's say. We want to be repeatable, testable, transparent, and we work open access because we work with public money.